students, so welcome to another video where in this video I'm going to guide you on understanding geometric progression. So geometric progression is actually a sequence in which the next term, in which the next successive term is multiplied by a constant. Now for arithmetic, we know that we need to either plus or minus. So for this we need to times. Now here what happens is, let me show you. For example, you are given a term, and you need to find the next term. So what we can do is we use the formula to find the term Tn equals to AR n minus 1. So this formula is something that we need to know and memorize. If you keep practicing, it's very easy to memorize. So what happens, let me give you an example here. So let's say you're given a geometric progression of 128, 64, 32. Now find the 12th term of the GP, geometric progression. Now what you're going to do is, of course, first you need to know what is your A. A is actually your first term. What is your R? R is your common ratio. For arithmetic, it's common difference. So for geometry, it's common ratio, and n we know as the number of terms. Now since we know that we are going to find for 12th term, we just substitute the values. So here it will be T. You're finding T12. So your first term here is, this is first term, second term, third term. So first term is 128. What is our common ratio? Now how to find the common ratio? So we will actually take the second term divide the first term, which is 64 divide 128, which we actually obtain 64 divide 128, we get 1 over 2. And now we can find our 12th term. So T12 is equals to A 128 times R. R is 1 over 2. N minus 1. N is 12. 12 minus 1 is 11. So here we can key in our calculator 128 times 1 over 2, to the power of 11. So this one you can include in. So you obtain 1 over 16. So the final answer is 1 over 16. So now next, if let's say you are required to state the formula. So for part B, state the formula for the n term. What is n term? Meaning that the term that you can't define. So meaning that you're just referring to the n. So what happens here is, this is your formula, Tn equals to AR to the power of n minus 1. So our A is 128, our R is 1 over 2, so our n is just n minus 1. So here we can actually simplify this. So how do we simplify is, find all these in base of 2, meaning that we change 128 to base of 2. So 2 to the power of what is 128? So 2 to the power of 7 is 128. Now, so we change this 2 to the power of 7. And here becomes 2 to the power, 1 over 2 to the power of n minus 1, because we times in the power. So now 2 to the power of 7 times 1 is 2 to the power of 7 over 2 to the power of n minus 1. So here we can solve and simplify. So what happens is 2 to the power of 7 minus n minus 1, which is equals to 2 to the power of 8 minus n. So this will be our formula for the n term. So we change this to base 2. Okay, so now let's look at sum of first n terms for geometric progression, where you have this formula. Okay, the sum of the first n terms is given by a times 1 minus r to the power of n divided by this 1 minus r again. But you only use this if your common ratio is less than 1. If your common ratio is more than 1, then you reverse it. Okay, you write the r to the power of n minus 1 and you just copy back that below. Now let's look at how we can apply this in the example. Now find the sum of the first 10 terms, okay, for this geometric progression. So for a, now for a, do we know our a, which is the first term? Yes, this is the first term, second term, third term. So our a is 7. What is our common ratio? Common ratio is 14 divided 7, which is 2. So is 2 more than 1 or less than 1? So it's definitely more than 1. What we're going to do is we're going to use this formula for our sum. So to find the sum of first 10 terms, we just replace the values. A is 7, R is 2, 2 to the power of 10 minus 1 divided by 2 minus 1. So we can of course solve this using calculator. So here we obtain 2 to the power of 10 minus 1, okay, times 7 divided by 1. So the answer is 7,161. Now this is for part A. Let's look at part B. We have this as first term, second term and third term. So our A is negative 4. Our common ratio is negative 2 divided by negative 4, which is 1 over 2. 1 over 2 is less than 1. So we are going to use this formula. So it's going to be S10 equals to A, which is negative 4. 1 minus R, 1 over 2 to the power of 10 over 1 minus R. So here again, can key in our calculator. So what we obtain is, we solve the bracket first. So 1 minus 1 over 2 to the power of 10, okay, times negative 4 and divided by 1 minus 1 over 2. So final answer we get as negative 7,127 over 128. So our answer is in mixed numbers. So this is how we find the sum of the first n terms. Now let's look at finding the sum to infinity. Okay, now we look at finding sum of to infinity, where we use this formula, which is a over 1 minus r. Okay, so we are given this geometric progression. We know our a, which is 12. We know our r, we can find 8 over 12, okay, which we simplify, we get 2 over 3, okay, and that's all. So sum to infinity will be a 12 over 1 minus 2 over 3. So keying in this in your calculator, 1 minus 2 over 3, 12 divided by this answer, we obtain 36. So the sum to infinity will be 36. So this is quite simple. And actually this is also very simple. It's just that for this, you need to find out whether the common ratio is less than 1 or more than 1, so that you can apply the correct formula.